Good morning. No. Welcome to the second talk within our Prometheus track. It's a deep dive. Some of you attended the intro. Welcome to those. You'll learn something new as well. Thank you. So I'm Richard. I did a lot of things. I'm currently building a data center. I'm a Prometheus team member, founder of Metrics, and this is Frederic.
Hey. So yeah, I work at Red Hat, and I basically work on everything Prometheus and Kubernetes and everything that connects the two projects, basically. So yeah, let's get started. Show of hands, like how many people are have heard of Prometheus? Hopefully that's everyone in this room. Okay. Who is considering using Prometheus? Okay, that's less. We'll convince you. Sorry? Okay, well, that's even better. Okay, maybe who is not quite using it in production, but like trying it out? Okay, that's good. And who's using it in production? That's a lot. Nice. Okay. So yeah, Prometheus is a monitoring system that was inspired by Google's Borgmon. It was founded by a couple of ex-Googlers who like knew how things worked at Google, and they're like, well, wouldn't it be nice if we had something like this open source? And it really came out of a need by themselves. They were working at SoundCloud at the time. So yeah, and it's Prometheus is a time series database. There are other monitoring systems out there that are not necessarily time series databases, but Prometheus is. And you can see that by the super simple data model, which is just every timestamp is a UN64, and every corresponding value is just a float 64. And that's quite literally what we write to disk. Yeah, and the way that all of this works is that Prometheus target just has an HTTP server that exposes metrics on some path. And then Prometheus comes around and collects all of these metrics. So Prometheus is a pull-based system. But what's really important to understand with Prometheus is we're really just about metrics. It's not about logging. It's not about tracing. And that's deliberate. We acknowledge that those topics are also important, but it's not what we're fixing or not what we're trying to solve. And Prometheus itself just has a query browser, basically, where you can do exploratory viewing, querying, and if you want to do dashboarding, you do that with Grafana. And so I guess a lot of people here are already using Prometheus, so I don't really need to sell you on it. It's great. It scales super well. It has a great query language to explore all of this data. And I think what most people appreciate most about Prometheus is that it's so simple to operate, and it's just reliable and super efficient. So yeah, some flashy words. It's super nicely integrated with all this cloud technology. So with Kubernetes, for example, we have a Kubernetes service discovery. So when pods come and disappear, Prometheus keeps up with that and dynamically reconfigures itself. But in itself, Prometheus is a very monolithic application, which means everything is it's all one binary, and it does all of what I've just said within that one binary, which kind of sounds weird, but it's actually what makes it so reliable and so simple to run, because it's just this one statically linked binary that you put on your server, and it just works. And the reason why we're doing this is just we want to build reliable and resilient systems. So that was kind of the intro, and now we want to deep dive a bit into what has happened lately in Prometheus world. So in Prometheus 2.0, which was pretty much exactly released a year ago, like a year and a month ago, and for that release, the Prometheus team rewrote the entire storage backend. So previously, Prometheus was based on LevelDB, and basically every single time series was a single file on disk, and samples would just be appended onto those files, which is great, but it turns out when you have a lot of time series. Okay. Yeah. So we rewrote the backend, and we introduced better new staleness handling, and the remote read and write APIs got a little bit more stable, but they're still being reworked a bit to be actually stable. Yeah. So in Prometheus 1.x, as I was saying, we had one file per time series, and that's nice and easy to implement, and it works fairly well. But when we are in super dynamic environments like with Kubernetes, that becomes a problem, because if we have hundreds and thousands of targets that each expose hundreds of thousands of metrics, that easily becomes a couple of million files on disk, which is not particularly well handled by a lot of file systems. And it's not efficient. So because of all of that, we yeah. So what I just described is churn. When time series, new time series come all the time and get stopped. So we have lots of them that are short-lived. Yeah. So if we look at that on like a visualization, we can see that this is not very well like distributed anymore, right? In a very static environment, we would just have continuous lines of dots where we don't have to create new files all the time, and we wouldn't be creating millions all the time. But what really makes the value of Prometheus is querying it, right? So not only do we need to open all of these files, we also not only do we write to them, we also need to read them to be able to do all this great querying that Prometheus allows us to do. And how we change this in Prometheus 2.0 is that instead of having one file per time series, we actually have time-sliced databases that are individually fully functional databases, and they're just slices of 2 hours of data. And there are just a handful of files per database, basically. And yeah, as I said, this was completely rewritten from scratch. And in order to ensure that all the things that we were intending to solve are going to be solved, we had a relatively complex test setup where we were ingesting a lot of metrics per second with a lot of churn. So we have a GKE cluster where just every 5 minutes we scale deployment up to like 500 targets, and then again down to 300 targets, up to 500 targets, and so on. And what that does is it just creates lots of targets, which means lots of churn and super short-lived time series. So that puts a lot of stress on Prometheus. And with that kind of setup, we were able to ensure that we actually are meeting our goals. And we did. We have super significant resource consumption improvements. I mean, these numbers kind of vary, right? These were some of the best results that we've seen. We've also seen some setups where resource consumption is actually the same as in 1.x, but generally speaking, resource consumption is way, 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 way better. And I think the reduction of on-disk size is pretty general, because all the metadata of millions of files is actually pretty expensive on disk when it becomes millions of files. But now we just have these handful of files per 2-hour slot, and that means we never get into that kind of scale. So in Prometheus 2.0, we released all of this, and we had really great reception of this. So what's next? So now we're working on making the remote read and write APIs much better. We've already improved them a lot, but there's also some more ongoing work that Richie is going to elaborate on. And lots of people actually started implementing these. So if you have an existing time series database that you are comfortably scaling, you can totally use Prometheus as like an ingesting front end and just send all of these samples to your existing time series database. And to complete all of this work, remote write currently is actually, it was basically when we initially implemented it, we just did the simplest solution to the problem, which is whenever Prometheus scrapes data from a target, it would just write all of those samples to disk and immediately send it off to the remote storage, which is great. But it turns out that we had to buffer these things in memory, and if you have a large buffer, then this kind of thing can explode. And if your remote read backend goes down, then you just always have ever-growing memory usage. But it turns out we actually already have an on-disk buffer to use, which is the write-ahead log. So that's what we're implementing right now, and it's probably going to be released in Prometheus 2.7, which should be released at the end of January, beginning of February. But within the like 2.0 to 2.2 time frame, we also had a security audit sponsored by the CNCF, done by the Cure 53 people. And basically, we knew, or we kind of anticipated the result, which is we didn't ever care about security features in Prometheus, so there's not really any security flaws. But this is also, like, at the same time, we were also thinking of introducing security features. So at the...
Actually decided to.
Yes, sorry, this is what I was getting to. So at the Dev Summit in Munich in August, we actually decided that Prometheus will have native support for TLS going forward. But there's just a couple of things that we need to figure out, like escalation processes and stuff like that, which because we didn't have security features, we didn't have this set up, and we're going to work with the Cure 53 folks to make sure that all of this process is also well thought out. So we did the Prometheus 2.0 release, and that release in itself was super stable because we trialed it for months, and we had so many pre-releases, but then every single release after that until like Prometheus 2.3.2 was like really unstable, and we realized this, and we took that as feedback and decided, also in the Dev Summit, that instead of just doing a release whenever we are going to do a release, we are now going to have a set cadence of releases, which means we have defined period where there's going to be implementation work going on, and so that reduces the surface of potential errors. But yeah, Richie is going to talk a bit more about that, but we did apply that, and then 2.3.2 was actually the true first stable release in the 2.x release train, because in 2.0 itself was very stable, but it had some semantic errors. So yeah, if you're super concerned, run 2.3.2. I think that's what we're running in production as well. Yeah, and then over to Richie.
Test. Okay, so let's try it like this. Yes, it actually works. So as you can see, we put a more or less arbitrary gap between the 2.3 and the 2.4, and this is precisely for that reason. Of course, for us, this 2.3.2 was more or less of a watershed moment. We had a moratorium where no new features were being added, and people were screaming and shouting because they wanted to add features, but they weren't allowed because we had a moratorium, because we tried it differently before, and that just didn't work. So to us, this was really like a large moment in the history of the project. Of course, we really changed how we worked for quite some time, And after that, we actually adapted changes during the Dev Summit where we committed to doing it the same way. So if we ever enter this phase of instability once more, we will have a moratorium. No one wants to have moratoriums, so hopefully people will avoid it. So what did we decide to do? Pretty simple. Every 6 weeks, we mark a new release candidate. And we just work on this release candidate. It's being improved. When we don't have any error reports anymore from the people running canaries and such, then we basically release. Totally distinct from this release process, after 6 weeks from the last RC, we cut the next RC. So all those considerations about, hey, if we push and shove in this a little bit, then the release after next will happen a little bit earlier, go away, because you have this fixed RC cycle anyway. And you can even plan for, okay, I want to have my holidays during that time, so I'm not going to be the release maintainer for this one. So this makes it a lot simpler on a lot of levels that we have done this. Yeah. So then we had quite some optimizations in between 2.4 and 2.5, I think, where Brian did tons of work of PromQL, and for some functions he actually had a 5 times reduction in time and a ton of reductions in garbage collection, which you don't always notice it, but when you run into those cases, you really notice that it's just a lot quicker than it used to be in those cases. Then we have long-term storage. So it's one of the last things within Prometheus proper which have not been really tackled, which is even more of an issue, because if you're running Prometheus proper, we actually suggest you just run more Prometheus servers. You need to scale, run more. You need to scale more, run even more. Maybe toss on some federation or such, but basically run more. But all these are islands of data. So if that one instance goes down, that data, it goes down with it, which is probably not the best thing to have. Also, we don't currently do backfill, so you can't even copy this data over into other Prometheus instances. We are working on backfill. It'll happen soon, but still, as of right now, you don't have backfill. So how did we tackle this within the last few release cycles? First and foremost, we now support snapshotting. So if your system is able to snapshot a system, you can already make proper backups of your data. And this remote read-write integration allows you to just push your data to someone else. Obviously, you're not actually solving the long-term problem. You're just shifting it to someplace else. But it's hopefully another place where you have better tooling for actually solving that issue. There's tons and tons of projects which adapt to this. I think we have like 15-ish or something. Yeah, I think it's roughly 15 projects which are working with our remote read and write API. So you have a ton of options to push your data to. Cortex, which comes out of Prometheus basically, and Thanos would be few of them. Also you have Influx, you have tons of them. Of course, as we saw earlier, that's the next thing. We now have blocks. We don't have this one file which goes on forevermore, or maybe not. We have blocks which are clearly delineated, and after those 2 hours, by default, you start a new block. And this looks awfully like something which you could put in object storage, which is what Thanos is, where basically also people from Prometheus team forked the code base and started putting the storage into object store, which is a nice way to scale. Cortex, I should probably mention, is doing the same thing, but on the index level where you can scale horizontally. We are also looking at merging those two back together. As we have a write-ahead log, you can also send this over the wire along with your remote read-write APIs. So all of a sudden, gaps in network connectivity and such, you can fill those at least to some extent. And there, I should put 15 for the next version. Anyway, we are not endorsing any version. We might have preferences amongst ourselves, but those are personal preferences. We deliberately decided not to be the kingmaker and say, okay, this one thing is what you should be using. This is not how we operate and not how we want to operate. We might at some point actually suggest that people start using something specific, maybe for a specific use case, but at the moment we deliberately do not make this recommendation. If anyone is claiming that their product has the stamp of approval, they're probably lying to you. Just saying. Then we have lots and lots of testing improvement as of recently, especially in the last in the 2.5. We have actual unit tests for alerts, which is great. Of course, you can test that your alerts actually work when you have certain types of data or certain kinds of data in your backend. And we want to get away from this only us doing testing for our own stuff. We recently also, for example, enabled in our CI pipeline that we are doing load tests against those commits, so we can see if we have any performance regressions, all these kind of things. So that's all obviously also something which we are trying to do. But this doesn't go far enough. This is just our stuff. And we want to enable Prometheus users to test all their stuff as well, to make their deployment testable. And this is something we are actively working on to just improve and improve and improve. But we are also going a little bit beyond just that, what I just talked about. Something which is not really firmly on the roadmap. It might happen 2.8, maybe, whatever. ACID databases is probably a concept I don't really have to talk about. We are missing one of them. It's isolation. The thing how we want to solve isolation or how we will isolation is relatively simple and highly complex at the same time. We have a monotonic counter. It's just up, 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 up. Every write gets one of those IDs. And basically, as long as this ID has not yet been committed, it will not show up in any of the queries. And to make it more efficient, basically, as soon as you know this one has been saved properly, all older IDs automatically also become marked as saved and persisted, and so they can be returned in queries and such, or used for calculations or what have you. And basically, if we don't persist something fully, or if a scrape fails, we just toss away that data, and at some point we just go beyond that with our counter, and then everything's fine. If we crash or anything, we just toss away the data once again, and the counter keeps us from doing anything wrongly, and it just starts at 0 again and goes up. So, but there's even more. We like to say, well, especially I like to say, that we really want to change how the world does monitoring, and we're being serious about this one. One of the single most powerful things which we have within Prometheus are labels. Of course, I see people nodding, that's good. It's just so insanely more powerful. And the thing about labels is, they are encoded in our exposition format. So anyone who is using our exposition format, and this is quite a few projects in the meantime, already support to some extent at least labels as opposed to hierarchical datasets, which is great. Still, some companies, some projects have issues with supporting something which they see as competing, which I can understand on the one hand, on the other hand, maybe not as much, but whatever, let's just fix it. So we are spinning out the Prometheus exposition format into its own thing. It's called Openmetrics. We had a kickoff just last year at Google London, are working on writing an RFC. That's actually me, but I've been time blocked for the last few months. Prometheus and the Python client library already support Openmetrics. So if you use the most current version of those two, they will auto-negotiate using Openmetrics in between themselves without you noticing. We have stuff in there at that repo. I already uploaded those slides, so you don't have to take pictures, it's fine. But we want to go also just those metrics, at least within that context, not with Prometheus, but with this whole observability space and story. So what Openmetrics allows you to, it allows you to attach exemplars to histogram buckets. So you can, for example, say my trace is in this and this latency bucket, and you can just jump from that really bad latency directly into a trace, which is really, really powerful to just go into stuff. And if you look at, for example, OpenCensus and SecDriver, those will support this. And Prometheus will probably never, ever persist exemplar information, just discard it, which is totally fine, as long as they keep speaking the same language to talk to each other. We are also trying to go more beyond this. Open Tracing is interested, Cloud Events is interested. We had this observability sidetrack actually already during this conference. And the goal is to have this one standard which is really well formulated and well engineered, and they all support labels, so you can correlate your data quite easily with each other and just basically like this change how stuff is done. There's a little bit of interest. It's easily 3 times that, but I stopped updating once I ran out of space. And so, yes, we do want to change the world. We will always, and this is a hard promise, core Prometheus proper will always be simple and resilient to operate. It will most likely always be a single binary. We are working on other stuff as well, but this is one of the promises of Prometheus proper. The most important thing we have within Prometheus, and the one thing which we take most care that it will always work, is going from your raw data to your alerts, to alert you that something's on fire. Everything else is nice, but it's secondary. That is the single most thing we are doing within the project. Yeah, we are also talking to hardware vendors. That is going slowly, but not too bad. And we are always trying to, unless you're like a large search company or something, always support whatever scale you might have tomorrow already today, and more than that, just so you can grow into this and just toss more metrics at us. Yeah, here are a few relevant talks which you would probably like to see. Again, you don't have to take pictures, and I hope you have lots of questions.
I'll come around.
Hey, sorry for my voice. Is there a maximum of metrics that Prometheus is able to retrieve simultaneously?
So Prometheus is, at least starting with the 2.0 release, is largely just resource bound. So whatever can go over the wire, it can do. Like, it's not limited in some technical sense. It's just whatever the hardware allows you to do, Prometheus is going to do. I mean, there are still like optimizations and tweaks that we can do, but it's like generally it scales with the hardware.
There's one thing where we limit to 11,000 data points in one query, but you can change that. It's just a safety mechanism, but it's a config flag, so you can just disable or change it. More questions?
Yeah, can you touch a word about scaling Prometheus with multiple cores? And for example, when you have a lot of targets and you have multiple Go routines, and how do you use a large number of cores to scale?
So as of today, a good number would be to say 200,000 samples per second and core. That's something you can consistently ingest with Prometheus. So as long as you're staying under this limit per core, you are most likely fine. If you want to go to absolute extremes, it's always a good idea to do your own testing and try and break things. And once you broke it, please make a blog post and tell us how you broke it and when it broke. But yeah, this is a good number to start with.
Yeah, always keep in mind that this is like the most expensive thing in Prometheus still is to create a new time series. So all of this resource consumption is very much based on how much churn you're going to have. We optimize churn for churn a lot in 2.0, but it's still basically the most expensive operation to do. Sorry.
Do you recommend for the local storage to use something? Do you recommend for a local storage to use something like EFS or NFS?
No.
Instead of having multiple isolation data and do backfill?
No.
Any particular reasons why not?
It'll break. Or it probably won't break, but it'll be more pain than it should be. You're introducing stuff, complexity, latency at a level where you don't want to have it. Just don't.
So Prometheus also heavily relies on mmap to work correctly, and over a network file system, that's difficult to actually get right. So we've seen a number of issues with NFS already, which is why we officially say that we don't support it. Where if you give us an issue and we can reproduce it, we're probably going to try and fix it. But I, for example, don't run any of my stuff on network disks because of this. Yeah. I think.
Is there any plan to support replication in Prometheus across nodes, the data replication?
What do you mean? I don't get the question.
As in two nodes sharing the data, just like a MySQL database or Postgres cluster.
You can already get the data out of Prometheus. Basically, you always run PromQL queries, no matter if you want to just have the most current data, if you want to have a graph, if you want to put it into Grafana, if you want to have an alert, a recording rule, or something for federation. It's always basically the same. It's always PromQL. And in the background, you always return JSON already. So you just basically make a request against the API and you get JSON back.
So I think you were basically talking about making Prometheus a distributed system, and we're not planning to do that. This is it's like really the core thing about Prometheus is it needs to be super resilient, and if as soon as it like relies on network for just querying, for example, it's not going to work anymore.
Ja, war als nächstes?
Which one?
Der ganz vorne.
Yep.
Could you talk more about how remote write works, and if we don't really want to keep any metrics locally and we have a good solution on the side where we can also read from there, how would you recommend configuring it?
You need another endpoint where you just write the data to and you configure without local disk. That works. It's a config flag.
Actually, you can't do no local disk anymore.
Yeah, okay.
But as we were saying, like we're implementing the basically replicating the write-ahead log. So you basically only need the most recent 2 hours of data is what basically is a persistent buffer on disk, and everything else you can just set your attention to 2 hours, and it will never keep the persistent chunks on. 2 hours is a must, yeah. From 2.0 onwards.
Ich glaube, er war als nächstes, aber ich bin mir nicht ganz sicher.
No,
I think that guy.
behind you.
Have we thought about removing the remote read and remote write models and API functionality from Prometheus Core so that it's easier for like external applications to consume those models and libraries?
Not really. But
I don't know. Maybe I don't understand the question, but how would removing help others? What do you mean?
If you're writing something that's consuming remote read or remote write, you have to consume all of Prometheus.
Oh, okay. So basically, what you're saying is, have we thought about like making vendoring the relevant aspects better? Yeah. Okay. That's interesting. That's good feedback. We haven't heard of this before. Basically, the question was about how can we reduce the surface of stuff that needs to be vendored when people want to build these integrations. No, I don't think we've actually considered that, but it's great feedback. I don't know who was first.
So if we see one Prometheus instance consume much memory, so just say there are data ingesting and there's data compaction and there's querying. Can you suggest which part might be the the most part to consume memory? How we can troubleshoot that?
Yeah, that's probably one of the hardest things, like particularly because querying is can use a lot of memory, because basically what you're doing is you're loading all of these samples from disk and then doing computation on it, right? So at some point in time, the actual raw data was in memory, and so yeah, that can take a lot of resources. To troubleshoot that, I would just recommend like taking profiles and sending them to us. We actually have the prom tool. You can run prom tool against the Prometheus server. It's like prom tool debug, and it'll get all the relevant profiles, and you can just like open an issue and we can look into the data. Yeah.
Can you please explain more about the snapshotting backups and recovery, and where they get stored or how to access them?
You just snapshot your VM or whatever, and the format you have on disk is safe when you snapshot your block device, and that's basically it. Yes, it's still the same storage. So if you were using LVM,
Yeah,
for
no.
example, you could just create a snapshot and it'll be consistent, and that wasn't the case with 1.x. It often worked, but there was no hard guarantee. Now, basically, the worst what can happen is you lose 2 hours of data.
Yeah, so like in terms of the database terms that Richie had on the slide earlier, Prometheus 1.x wasn't, didn't have the atomicity characteristic, which means like we can always guarantee that whatever is on disk is actually consistent. Yeah, so when Prometheus crashes or something, we can actually properly recover from that. And that has the same characteristic for snapshotting. And there was a follow-up up here, which was good. So there is also a functionality for actual backups in Prometheus, which basically, because Prometheus, the chunks are immutable, so all that it really is just it does a hard link on the on the databases, and you can do like back that up to some external storage.
So yeah, labels are absolutely awesome. Can you help me understand how, as you add more labels to a time series, how that will impact performance?
At some point, it'll start impacting performance. Usually, so when you say more, what do you mean? Like 5, 10, 100?
Right now, we probably have around like 30 labels on our time series.
Too much.
It's too much.
So
or I guess in what way is it too much?
Just from the conceptual point of view, just from the sniff test, I would assume that you would be able to push some of those labels into Infomatrix and then just group this information into the other metrics when you need them. 30 is, I don't think I ever saw someone using 15 properly. Okay. So 30 just is too much, unless you're doing really, really extreme stuff. But you should look into Infomatrix. That's probably the best thing to do.
I think the general kind of like guidance on labeling is you want to have only that information in labels that actually uniquely identifies the time series. So if you do actually have 30 labels that only in that combination uniquely identify the time series, maybe it's fine, but probably not. Yeah.
So in the remote reads, the labels weren't exported well. So I was running into an issue where Prometheus, we had PMM per Kono's monitoring framework, and we already were running Prometheus with all of our node exporters and everything else, and we just wanted remote reads from their tool to ours, so that we would be the data source. But what we found out is that the Grafana dashboards wouldn't bring the labels into the dropdowns because they weren't actually exposed via the remote read endpoints.
Did you use the most current version? And if yes, could you file a bug?
Yeah.
So it should probably not happen. Yeah, that sounds weird.
Sounds like a bug. Okay. Okay. Yep.
This is the boring part about security. You mentioned there's a plan to add authorization and HTTPS and all that stuff. Is it only on Prometheus Core, or also the exporters will support that?
The supporters as well.
Yeah. So this is supposed to be like a comprehensive security story. So previously, what we said was like if you want to have exporters be authenticated, then you have to put a proxy in front of it or something. And so yeah, we do want to build it into Node Exporter, into I don't know, all the exporters that we have in the Prometheus org. Yeah, actually we're going to start with Node Exporter and basically extract all the common things, then out of Node Exporter into the common repo, and then share that across the repositories.
It goes into the libraries basically, so it will permeate through the ecosystem. If you're using our libraries, then yes. I think maybe we take the last question and then Chris. Yep.
Can you elaborate a bit on Infomatrix, if I understood you correctly? What is this? Because I was just trying to Google it and I failed.
Basically, it's _info, whatever _info, and then it just, the value is always 1, and you put labels which you want to correlate into other stuff, and then you have something which identifies between this info metric and the other metrics. But it's probably best to take this downstage, because if anyone wants open metrics ribbons for their badges, I printed plenty. They are also rainbow, so it's also a political statement.
Yeah, maybe I can also answer that question with a concrete example. So in the kubestate_metrics exporter for Kubernetes, sorry. Okay, we're way over. Then I'll